All right, good people. I want to do two from here. Actually, let me just do one because I think, or let me do two. Yeah, let me do part A and part C. I'm sorry. This is video number four um, for section 1.15. So we're taking a limit at infinity. That means we can ignore everything except the largest term in the numerator and the denominator. So in the numerator, that would be this. This is the largest term. Not always the first one, be careful. And then the biggest term in the denominator, that would be this. Can I reduce? I can, but I'm about to find out that when I reduce, I'm left with 2x over 3. So if I plug bigger and bigger numbers into the numerator and the denominator stays the same, well, then this is just going to grow and grow and grow and not get any smaller and not level off. This is going to go to positive infinity. And yes, I know that the limit does not exist, but I know why it doesn't exist. It doesn't exist because it goes to positive infinity. Excuse me. What this is telling us is that the function doesn't have a horizontal asymptote. It just goes up and away forever. I guess to the right. Yeah. So yes, the limit doesn't exist because of positive infinity. And then I wanted to do letter C. And this one is a funny one. Not funny, haha, but funny, I only have one function on top and I have one function on the bottom, right? So where does this go? Well, I know that the denominator is going to go to infinity. And I'm going to put that in quotation marks because I can't substitute infinity. But it's going to get bigger and bigger and bigger. Whereas if I go and substitute bigger numbers into the numerator, I got to remember what sine function looks like. So sine function just waves, right? So what's the highest y value that sine can go to? Positive 1. What's the lowest y value that sine can go to? Negative 1. So that means whatever values I plug in, I'm always going to get answers. I shouldn't say x. I'm always going to get answers that are between negative 1 and 1. And that's it. It's not going to get higher than 1. It's not going to get lower than negative 1. But the bottom just keeps growing and growing and growing and growing. So it's almost like it is going to level off. It's going to go above the x-axis, below the x-axis, above the x-axis, but it's getting smaller and smaller and closer to the x-axis, meaning that this is going to 0. So even though sine does not approach a specific value because it only oscillates between positive 1 and negative 1. So I know that the denominator is going to grow faster, and this is technically bottom heavy, and we know all bottom heavies approach 0. A couple of notes, and I'm not going to fill everything in, but I need you to remember that exponentials are more powerful than polynomials as x approaches infinity. What I mean is they grow faster. So whenever I have an exponential, it's always going to grow faster than any polynomial. Polynomial will be x to the third or x to the fifth, even x to the 100th. The exponential will eventually beat it out and grow faster. And then the second thing to remember is be careful. We've looked at examples where x is always approaching positive infinity, but x could approach negative infinity. So be careful with those. All right. So here's a perfect example. I'm looking at letter A. This is a limit at infinity, even though it's approaching negative infinity. So let's take the limit as x approaches negative infinity of the top and the bottom, but the biggest term on top and the biggest term on the bottom. And reduce it as much as you can. So we're taking the limit as x approaches negative infinity of 2x over 3. Does that look familiar? But this time, when I plug in big negative values, I'm just going to get more and more negative. So this limit is going to go to negative infinity. And that's it. So the process is the same, right? But just be aware and always be mindful of the fact that x is it approaching positive infinity or is it approaching negative infinity? Because that's going to determine where that goes. And then I want to look at the one right under it. So I'm going to take, this is a limit at infinity. I'm going to take the limit as x approaches infinity of the numerator, the biggest term in the numerator, over the biggest term in the denominator. And this time I have an exponential. And what we just said, what we wrote in that little box was that exponentials outgrow polynomials. It doesn't matter that it's x to the 99, e to the x will eventually beat it out and it's going to grow faster and faster and faster. And so this is what we would call bottom heavy, and this is going to approach 0. What about letter E? Well, a limit at infinity, right? And so I'm going to take the limit as x approaches negative infinity of the numerator. The biggest term of the numerator is 2 to the x. The biggest term in the denominator is 2 to the x. And yes, I do need to concern myself that I'm plugging in x's that are getting more and more negative, but this is going to reduce down to 1. So even though and by the way, as x approaching negative infinity, that means I'm moving to the left on the graph, right? And this is saying it's leveling off on the left side. If you have questions about some of these other ones, we can certainly tackle those. And something like letter C, don't be frightened by the square root. Remember, we're focusing on the biggest term. So even this, take the limit as x approaches infinity of the square root of 4x squared, and then in the denominator 7x. So reduce it as much as you can, and you're going to find that you're going to be left with 2/7. And there's the limit. All right, we're going to pause here, and then we'll come back to finish this up.